Hi everyone, this is a video on radioactive dating and radioactive decay, which are concepts you've been learning about this week. So, just to give you a little bit of a background, the time it takes for half the number of radioactive atoms to decay is the half-life of the element. And this is a video, an activity which I'll show you, in which you will use pennies and a stopwatch or clock to model half-life. So, radioactive decay and half-life refer to this concept of certain elements like carbon and uranium being found in things like rocks and fossils. And over time, the atoms, these radioactive atoms, will decay or disappear. And depending on how much is left in the sample, you can actually figure out how old certain rocks and fossils are. And so this is an activity where you can use pennies to represent the atoms of a radioactive element like carbon or uranium. And to do this activity, you first need 100 pennies, and I have 100 right here. You will also need a cup, an aluminum pan that's large enough to hold all these things, and I'll show you the pan right here. It looks like this, so it has to be large enough to hold all the pennies. And you also need a stopwatch or clock. And in my case, I don't have a stopwatch, so I'm just going to use my phone. Okay, let's get started. Okay, so if you haven't started your stopwatch, I'm going to start it again here. Now, I've placed all 100 pennies in this cup, and again, these pennies represent the atoms of that radioactive element. I'm going to dump all these pennies into a pan. Let me do that right now. Now, I'm just going to dump these in here and try to spread them out. And as you notice, one flew out, so I'm going to put it back in there. So, after you do that, you want to take out all the pennies that landed heads up and count them. Pennies that land heads up represent atoms of the element that have decayed. And you're going to create a data table in your notebook to record that number. So let me actually remove all the ones that landed heads up. All the while you're doing this, you want to make sure that you're not accidentally flipping over the other ones because they tend to land on top of each other. So I'm just doing my best to sort through them without disturbing the other ones. Okay, so you're going to take the remaining pennies, which you see here, those that landed tails up, and put them back into the cup. And these pennies will represent atoms that have not decayed. So let me actually do that really quick. And then you're going to dump these back in the pan again. And then you're going to take out all the pennies that landed heads up and count them. And then again, record your results in a data table. And then you're going to repeat this process 2 more times. And remember to record your results. And after the last trial, you're going to check and record the time shown on your stopwatch. And mine has been running this entire time. And then I'm going to eventually create a bar graph showing this entire activity in summary. So I'm going to do this 2 more times. Again, you take the ones that are left in here, tails up, put them back in the cup, dump them out. The ones that land heads up are decayed, so you remove them. Okay, that's 2 more times, and this is pretty much the end of this. And as you've noticed, the original number of atoms, or pennies, that I started with has dwindled. It's very little now. And so I'll show you what this means in terms of data and what it means in terms of half-life. This is the data for this activity. I tallied up the number of pennies that were heads up and tails up for all 4 trials. Remember that the pennies that were heads up represented the atoms that decayed each time, while the ones that were tails up did not decay, and I left those ones in the tray. I also created a bar graph which shows you the number of pennies that were left for all 4 trials. As you can see, although I started with 100 pennies or atoms, which is what they're supposed to represent, by the 4th trial I only had 5 left, which means that most of the atoms decayed over time. Between each trial you can see that the number that were left is roughly half of what it was the previous trial. And you can see that in the bar graph especially. The bar gets cut down by half each time. Half-life would refer to how long it takes for half of the atoms to decay. To estimate it, or to calculate it for this, I would take the total time, which is about 7 minutes and 30 seconds, and I was keeping track of that on my phone, and I would divide that by 4, because I repeated that process of removing the decayed atoms, or using the pennies to represent decayed atoms. I did that process 4 times, and if you take that total time and divide it by 4, I get about 1.8. And that means that roughly every 2 minutes, half of the pennies decay, or half of the atoms disappear. In summary, this activity models the radioactive decay of elements like carbon-14, which, depending on the amount of atoms, of carbon-14 atoms left in a sample, you can determine how much time has passed and therefore how old the fossil is. Just keep in mind that carbon-14 is only found in fossils of living things like plants and animals, and cannot be used to date things like rock layers.